Alright, so let's start with some problems. An airplane has a mass of 3.1 times 10 to the fourth kilograms and takes off under the influence of a constant net force of 3.7 times 10 to the fourth newtons. What is the net force that acts on the plane's 78 kilograms pilot? Now, according to Newton's second law, the acceleration is equal to net force over mass. Now, we know that the mass is 3.1 times 10 to the fourth kilograms and that the net force is 3.7 times 10 to the fourth newtons. We know that both the acceleration of the pilot and the acceleration of the plane is going to be the same. So using the mass of the plane and the net force, you can find the acceleration. Therefore, the acceleration is 1.19 meters per second squared. Now you have your acceleration and the mass, and you're just missing the net force. So when you do Newton's second law of motion, you see that net force is equal to 78 times 1.19 meters per second squared. That gives you a net force of 93 newtons. Let's go on to another problem. A boat has a mass of 6,800 kilograms. Its engines generate a drive force of 4,100 newtons due west, while the wind exerts a force of 800 newtons due east, and the water exerts a resistive force of 1,200 newtons due east. What are the magnitude and direction of the boat's acceleration? Now you need to consider all the forces. So first write out what they give you. The mass is 6,800 kilograms. Now there's a 4,100 newton force due west, and that's the way that the boat is moving towards. So that will be a positive force. Now the wind is a force that goes 800 newtons due east, and there's also a force pulling it back of 1,200 newtons. You need to take in consideration all of these when you find your net force. Now you have to draw a free body diagram, which is the representation of all the forces as it can be seen already drawn. So then you have to do 4,100 newtons, which is a positive force because that's the way that the boat is going, minus 800 newtons, which is the resistive force, minus 1,200 newtons, over your mass. It will give you your net force. It will give you your acceleration of 0.31 meters per second squared, and since it is accelerating and it's positive, it's due west. Let's look at another problem. In an amusement park ride known as Magic Mountain Superman, powerful magnets accelerate a car and its riders from rest to 45 meters per second in a time of 7 seconds. The combined mass of the car and riders is 5.5 times 10 to the third kilograms. Find the average net force exerted on the car and riders by the magnets. Now, because they give you initial velocity, final velocity, and time, you have to use kinematics to find your acceleration. So you have your initial velocity of 0, your final 45 meters per second, and your time of 7 seconds. At the same time, you know that acceleration equals change in velocity over time. So it's b final minus b initial over time. And when you plug in 45 and 0 over 7, it will give you a total acceleration of 6.42 meters per second squared. Now, you already have your acceleration and you already have your mass. You just need to use Newton's second law of motion to find your net force. So net force equals mass times acceleration. And when you plug in the values, you see that your net force is equal to 3.5 times 10 to the fourth newtons.